HCl. And then from there, we can use the reaction to figure out how many moles of Cl2 as well as H2O that we are producing. So first we're going to do Cl2. So we have 85 moles of HCl reacting, and 1 mole of Cl2 is formed per 2 moles of HCl. So given the amount of HCl that we are reacting, we are producing 42.5 moles of Cl2, and that is equal to N5. And now let's go ahead and do our water, which is going to be the exact same because of the stoichiometry. So 1 mole of H2O is formed per 2 moles of HCl. So we're forming 42.5 moles of H2O, and that is N6. And then next we're going to figure out what our N4 stream is, and that is going to be equal to the amount of nitrogen that we have going into the process. So we're just going to figure out how much nitrogen we're feeding to the process. So we're going to have 0.79 moles of N2 per mole of air. And we have N1 moles of air being fed to the process. So 0.79 times N1, which is 160.7, is going to be equal to 126.9 moles of N2. And that is going to be equal to N4. Okay, next we're going to figure out our final unknown, which is how much oxygen we have coming out. And that is going to be the difference between the oxygen that we're feeding in and the oxygen theoretical, so that the oxygen that is being consumed within the process, which is not the theoretical, sorry. So for 7, we're going to do oxygen. All right, so we have 0.21 moles of oxygen per mole of air. And N1 moles of air going to the process. And there are 2 moles of O, not O2, per 1 mole of O2. So we're just doing an atomic species balance here. And then coming out of the process, oxygen is present in N3, which has 2 moles of oxygen per 1 mole of O2. And oxygen is also present in water. So we have N6, which is 42.5 times 1 mole of oxygen per 1 mole of H2O. And we know N1, so 0.21 times N1, which is 160.7 times 2 minus 42.5 divided by 2. So N3 is equal to 12.5 moles of O2. And let's see, we did a group analysis, we solved using atomic species balance in our equations. Let's figure out what the composition is of this outlet stream as well. So total coming out is equal to N2 plus N6. So N2 plus N3 plus N4 plus N5 plus N6. And that is going to be equal to 15 plus 42.5 plus 42.5 plus 126.9 plus 12.5. So that is equal to 239.4 moles. So then our composition of the outlet stream can be determined. So HCl, O2, N2, Cl2, and H2O. So the composition of the outlet stream in terms of HCl, so it's 0.06265, and then oxygen 0.0522, nitrogen 0.53, and that is so high because nitrogen does not react. Everything that's fed in, which is most of the airstream, comes out of the process. And then Cl2, 42.5 over 239.4, 0.1775, and then H2O, where's that? 42.5 over 239.4. That is 0.1775, which is the exact same as Cl2. And go to part 2 of this video for parts B and C.